So another way that we simplify big O is we drop non-dominants. And so to explain this, I'm going to bring up the nested for loops that we had in the last video, but I'm going to add an additional for loop after the nested for loops. So now let's flip over to VS Code and take a look at this. So there is our new print items function there with our nested for loops followed by a single for loop. And then down here, we're going to pass that the number 10, and I'll run this. So I'm going to scroll to the top, and you can see that this starts with 0, 0, and then it goes down to 9, 9. Those are created by the set of nested for loops, and then that single for loop is going to print out 0 through 9. So now let's flip back. So this set of nested for loops ran O of n squared times, and then that single for loop ran n times. So the total number of operations was O of n squared plus O of n. Or you could write it like this. N squared would be the dominant term, and n would be the non-dominant term. So if you think about when n becomes very large, even if we use a number that is not that big, like 100, n squared is going to be 10,000, where that standalone n is going to only be 100. So that standalone n, as the number gets larger and larger, becomes less and less significant in this equation. So we simplify this by dropping the n and just keeping the n squared. So this rule of simplification is called drop non-dominants.